Ever wondered how software program can share code without duplicating it? That's the magic of dynamic library. In this video, we will learn what dynamic libraries are, why they are useful, and how to create one step by step. By the end, you will understand how program can use the same shared code seamlessly, just like a plug-and-play system. Before creating any dynamic library, first we should understand the concept of dynamic library. A dynamic library, also called a shared library, is a file containing code and function that can be used by multiple programs at runtime. But what does runtime mean here? Runtime is just the period when your program is actually running on the CPU, not when it's being compiled. Your program initially sits on the hard disk. It is just data here. When you execute it, it's loaded into memory and the CPU starts running it. That whole period is runtime. Runtime is equal to load time plus execution. Dynamic libraries are loaded and used by a program only when it's run. Let's create a dynamic library in C++. It's our source code of mathutils where we are adding two numbers. It is our header file for the source code. Basically what we are doing here, we are adding here two numbers and we'll call it dynamically at runtime. This function will be shared with other program. To create shared library or dynamic library, we need two steps. First, create object file and then create a dynamic file using flag-shared. Let's look into each. Step 1. First, we need to create an object file. On Mac operating system, we have to run command clang ++-fpic-c mathutil.cpp. It will create position independent code, and clang ++-shared-o mathutils.dylib mathlib.o create the shared library. On Linux, the first command will be the same, but on the second command will be changed to output from dylib to so dot. So the command will become clang ++-shared-o lib mathutils.so. -fpic ensure that the library can be loaded anywhere in the memory, and -share tell the compiler to make a dynamic shared library. Let's create a driver function. Here it's our driver function which will call the add function dynamically. So how to compile and link it? We will use the command clang ++main.cpp-l.l mathutils.o main. This will link against libmyso. Then we have to export ld library path equal to dot, which will tell OS where to find the library. Dot means current folder, and then we have to execute dot main. The program uses add from the shared library at runtime. If you update your shared library, the main automatically uses the new version without recompiling. So dynamic library allows code sharing across multiple programs. They reduce program size and simplify upgrades. Runtime is the period when the program is executing on the CPU, not when it's compiled. Remember, unlike static libraries, dynamic libraries load and execute at runtime. Now that you know how to create a dynamic library and understand runtime, in upcoming videos, we will see the difference between static library and dynamic library in much more detail.